generalized linear models for binary data using Navure. To demonstrate this procedure, we will use the Corn-David score test data from the test data repository. The experiment compared the damage caused by the fall armyworm to corn crops over time between two genotypes, a genotype with a biotechnology event, called protected, and a control consisting of the same genotype without the technology. The trial was conducted using a randomized complete block design with 3 replications. For each plot in a block, we evaluated a sample of 40 plants every 4 days at 5 different times using the Davis score. If the score was greater than 2, the plant was assigned a value of 1, otherwise, it was assigned a value of 0. These values are recorded in the DO2 column of the data set. These data are called longitudinal because the same plot was observed several times over time. This type of data requires identification of the unit being tracked over time. In this example, each treatment plot within a block is the unit we are tracking. Let's create an ID for these units. Click the Rows and Columns tab, select the treatment and block columns in the data table, and then click the Merge button. In the dialog box that appears, both columns are already selected. If not, select them. Click the OK button. A new column is created. It has a unique identifier for the plots within the blocks. Let's rename it Plot. The binary response variable is handled by a special type of model within the Generalized Linear Model framework. To account for the design and the longitudinal nature of the data, a generalized linear mixed model for the binary response David over 2 is fitted. To access this model, click the Univariate tab and then the GLMM button. In the dialog box that appears, select the DO2 column as the response variable and treatment, block, and plot as the class factors and day as a covariate. Click the blue play button to start the process. A new dialog box appears, with a navigation pane on the left containing 5 items. Each item presents different options in the middle pane, while the right pane displays the previously selected list of factors and covariates. First, examine the contents of the Fixed Terms tab. This tab has 2 panes in the middle, Family Options and Fixed Terms. The response variable in a data set is typically a mixture of random variables that belong to the same family but differ in the parameters that characterize them. For example, suppose we have a data set from a 1-factor, 3-treatment experiment in a completely randomized design. When we say that the response variable is a normal random variable, this is true only if the mean and variance are not changed by the treatments. Technically, it is more accurate to say that the response variable is a mixture of random variables that all belong to the same family, say normal. This is what the Family Options panel refers to. The default family is set to normal, which assumes that the response variable is a mixture of normal random variables with the same variance. The variable in question is binary. So, we will select the binary option. Note that this choice will cause one field to appear, named link function. The link function is not an easy concept to explain in a paragraph. But it establishes the relationship between the expected value of the response variable and the so-called linear predictor, thereby accounting for nonlinearity and ensuring that the estimates of the expected values and their confidence intervals will be in the range of the random variable. For example, in a model for binary outcomes, the default link function is logit. There are 2 other link functions that are commonly used for binary variables, probit and complement log. When you estimate the model, the estimated expected values are on what we call the link function scale. On this scale, the expected values and predictions will be in the real number range, but when we go back to what we call the response scale, which is what we use to report the results, they will be in the 0 to 1 range. This scale is interpreted as a probability scale for the event of interest. Let's shift our focus to the fixed terms of the model. Our primary interest is in understanding how treatments control damage over time. To do this, either double-click on the treatment item in the right pane or drag and drop it into the fixed terms pane, add the covariate day using the same technique, and also add the interaction between treatment and day. While our focus is on the treatment, it's important to recognize that the block can also contribute to variation. The complete randomized block design is used to proactively identify potential sources of variation in response variables. For example, we can consider different sites as blocks, each with different levels of potential damage to the crop. Although the difference between blocks is not our primary interest, it is important to recognize it as a source of random variation. Therefore, we'll label it as a random term. To do this, navigate to Random Terms in the left pane and double-click Block in the right list to add it to the random terms. Since the same plot is followed over time, there are correlated observations. To capture this lack of independence, we add plot as another random term. It is important to realize that plot is a nested random term within block. In generalized linear mixed models, this is indicated in two different ways. One is, as we have done, to label the plot as representing different items within and between blocks. The other is to use a syntax that can sometimes be confusing if you are not familiar with it. Navure has a button to add a term nested within others. Since there are two main terms in the fixed part of the model, one related to a factor, treatment, and the other to a covariate, day, the question arises as to which of these terms we will focus our attention on to generate the output. If we focus on the treatment, we will use the post hoc means comparisons method. However, the means comparisons are not independent of the covariate because an interaction term has already been included. Therefore, comparisons must be made for multiple levels of the covariate. This is not an inconvenience for Navure because it is easy to specify those comparisons for different levels of the covariate or covariates. If we want to focus our attention on the progression of the damage for each of the treatments, we should request the output of the fixed coefficient of the model to be able to calculate some quantities of interest such as the number of days to reach the 50% of plants with data score over 2 for each treatment. We will go through this last strategy. And check the Fixed Effects Coefficients option on the Output tab. Now click the OK button and wait for the output. Let's explore the output. Below the model title is the R script for fitting the model. If the column names involved in the model contain non-ASCII symbols, note that they have been changed in the script to contain only ASCII symbols. The model summary table provides an overview of the conditions under which the model was fitted and includes key statistics for model comparison, such as AIC and BIC. It also presents the deviance, an important metric that indicates the fit of the model to the data. This metric, when divided by the residual degrees of freedom, dF, of the model, serves as an indicator. Ideally, this ratio should be around 1 for a well-fitted model. A problem arises when the ratio exceeds 1, indicating a phenomenon known as overdispersion. The question then becomes, at what point does the ratio become problematic? While the answer is somewhat subjective, we contend that a ratio greater than 2 should raise concerns, but if it exceeds 3, it indicates a clear problem with the model fit. The ratio of deviance to residual degrees of freedom in our example is close to 1. Therefore, we can assume that this model is a good fit. The ANOVA table says that there is a significant interaction between treatment and day. This means that the magnitude, or possibly the direction, of the difference between the treatments depends on the day, and that the dependence of the response variables on the day is different for the two treatments. If we scroll down the results, we will find a chart which displays the progress curve of damage. It is clear that the control that do not contain the protection technology reaches almost the 100% of plants with data score over 2, in day 11, Meanwhile, for the same time, the percentage of plants with data score over 2 in plant with the protection technology is about 30%. A common statistic, used to compare curves of progress of damage, is to calculate the time at which the incidence of the damage reaches 50%. You can get a precise calculation using the fixed coefficients of the model, but you can get a very good approximation, graphically. Navigate to the Chart Results tab in the Report interface. Once in the Chart Results tab, find and click on the Y-axis tab. Look for the Add Horizontal Line button within the Y-axis tab and click on it. After clicking the button, move your mouse into the main area of the chart where the data is displayed. The mouse pointer should change to a cross. Click at any point on the chart. This will create a blue horizontal line. Double-click on the newly created blue horizontal line. This action will bring up a new set of tools on the ribbon. Within the new set of tools, find a numeric box labeled Value and double-click on it. Enter the value 0.5 into the numeric box and press the Enter key. This will move the blue line to the 0.5 position on the Y-axis scale. Still within the same tool set, click on the Add Vertical Line button. Move your mouse to the chart area and click anywhere to create a new blue vertical line. Drag the newly created vertical line until it intersects with the previously added horizontal line at the point where the horizontal line crosses the orange curve, Control Curve. Create another vertical line that intersects with the horizontal line at the point where it crosses the red curve, Protected Curve. Look for the Font button on the ribbon, toolbar, and click on it. Use the options within the font settings to increase the size of the labels associated with the blue lines. Now you can read the D50 point in the labels of the vertical lines.